0. Good afternoon and welcome to Mr. Mickleborough's Maths World. This is the way it is. This video is all about log and exponential modelling. So looking at some fairly basic examples to start off with. Got an example here from the textbook. Let's have a look at it. An amount of $1,000 is invested in a building society where 5% per annum interest is paid and it's compounded continuously. So continuously, that's where we're going to use exponential functions rather than the compound interest formula. So I like to, in this case, write down information as I go. $1,000 would seem to be some sort of principal, although we don't call it principal in this case, as we'll see. 5% per annum seems relevant. The amount is in the account after T years can be modelled by that equation. All right, let's get the equation down. A equals A0, E to the RT. And it's explaining what the trinomials are standing for. R is the continuous instant rate, interest rate I should say. Find the value of A0 and R. Okay, well that one's really a bit of a gimme because A0 is the initial amount. That's what A0 means. The amount at time 0. Okay, so our answer to A is that A0 is equal to our $1,000. And R is simply, now we don't write it as 5, we think of it as 5 over 100 because a percentage is a number out of 100. So R is going to equal 0.05. That should not be a problem for you if it is 5 divided by 100, or if you've got a more awkward one. Just do it that way, use your calculator. Write an equation substituting values of A0 and R. Sure. Okay, so A is equal to 1,000 E raised to the power of RT. So 0.05 T, just like that. I've replaced the values for R and A0. C, find the amount in the bank after 1 year, 10 years. Okay, so I'm a bit pressed for space here, so if I make use of this I should be okay. 10 years, well that means T simply equals 10 and we'd substitute that into our equation. Therefore, sorry, A, the first, it should have been 1 year, shouldn't it? T equals 1. Okay, so therefore, amount after 1 year, I put the subscript 1 there, is equal to the initial amount, which is $1,000, although we don't write the dollar sign, E raised to the power of 0.05 times 1. But of course, that's not going to affect anything there. So to my calculator, I would go, and I'd appreciate it if someone could do that now, and key in 1,000 times E to the power of 0.05. Whilst I'm getting that number from some kind person, I will have a go at the second part. And all that's requiring us to do is substitute 10 in place of T. So after 10 years, so A10, your amount is equal to 1,000 times E to the power of, now 10 times that is quite clearly 0.5, isn't it? So I'm just going to write it like that and perhaps someone can give me an amount there. Have we got an amount for after 1 year?
$1,051.27.
$1,051.27 it seems. Don't forget to use your amounts, your dollar and cent amount, so 2p only is good enough. What about for after 10 years? Do we have an answer to that?
$1,648.72.
$1,648.72. Many thank you. Okay, so you can see that your interest is accumulating nicely, especially after 10 years. Okay, what's part B asking us? How long will it take, to the nearest dollar, I'm not going to spend time on that, but to the nearest dollar, round that down and round that one up. Okay, remember, totally correct. How long will it take for the investment to double in value? Give your answer to the nearest year. I'm going to talk about that after I've done it a bit, because there's an issue there. Now, how long will it take? How long it take type questions means we're going to have to get to the value of t. Okay? You can probably imagine that the general strategy is at some stage, if we want to get to the values of the trinomials up here, we're going to have to take logs of both sides. Okay? So those how long questions, or what interest rate is required type questions, will involve taking logs of both sides at some stage. Anyway, how long will it take to double in value? Well, if it doubles in value, it means our amount has got to be $2,000, doesn't it? Okay, because the initial amount was $1,000. So, now let me think. Can I get that up? Yep, that's good. And in fact, like so, good. So we want our amount to equal 2,000. This is part D, by the way. So, we want $2,000 to equal 1,000. We know what the interest rate was. That was 0.05. That has not changed. And to repeat the point, our job is to get to the value of this t. First step would probably be to divide both sides by 1,000. Okay, therefore, 2, come back to you, 2 equals e to the power of 0.05 t. Now, can you see, gentlemen, that if I take the logs of both sides, I'm going to end up with ln2 equaling 0.05 t. 0.05 t. Therefore, t will equal, I'll come back to you, ln2 divided by 0.05. By the way, if you're dividing something by 0.05, you can take that upstairs and call it 500. So, do we have a value there, please? ln2 divided by 0.05.
13.86 or 14 years.
13.86 years. They wanted to know to the nearest year, so it will take 14 years to double. Now, why hesitate? These are continuous interest compounding problems. Generally, you would be aware that when you are talking about where things compound monthly, quarterly, annually, you do have to wait to the end of the period. So, you know, if this is compounding annually, you would have to wait 14 years to get your money, okay? They don't pay out in parts of years or months or whatever the period is, okay? So that's an example of how we use the taking log technique to model a situation. Can we please stop that one?